Hello, this is day 20, um, unit 3, which is chapter 4 in algebra 3. And this is solving radical equations. That's a D. Radical equations. And so we just did rational. This could be confusing. Sounds the same, but radical means having like a root in it, a square root type of thing. Doesn't have to be a square root, but in this case, it is. So, and it's a pretty straightforward process. You want to treat. Here's an example. You want to treat the root, the radical, as kind of like you would treat a variable when you're solving it. You want to get it alone on one side to solve it, but we have to treat the whole radical like that. So the radical needs to be alone before you do anything else, and it is in this case. There's nothing else on the left side other than the radical. Everything else is inside the radical, so that's fine. And then, so we'll raise both sides to a power. And the reason why is because a radical is an inverse operation as an exponent. It can be thought of that. If it doesn't have an index is a number right here, tells you what type of a radical. If it doesn't have an index, it's automatically a square root. And so a square root has an index of 2, and that's how it matches up with the square. Those are inverse operations. Just like if you took a square of 4 and then you squared it, we should get what we started with. The square root and the square would cancel each other out, and we'd get 4. If you did one after the other, square root of 4, which is 2, and then squared it, you'd get 4. So we did the same operations just back to back instead of canceling them out, and we get the same answer. So these inverse operations will cancel each other out, but we have to square the other side as well. Can't just cheat. So only thing we had to do is get the root by itself. It was by itself already. And then eliminate it by raising both sides to the second power. The left side, it cancels out with the root, 1 minus 4t. And on the other side, 2 squared is 4. And so we can solve this equation just normally. We would say subtract 1, subtract 1. That would cancel, and negative 4t is 3. We would divide by negative 4. So t is a negative 3/4. And in these problems, similar to the previous lesson we just had on extraneous solutions appeared in rational equations. And it was just, if you got a 0 in the denominator before, that can't exist, and it's an extraneous solution. Same thing could happen here. If I get a negative underneath the radical bar, it's not necessarily called an extraneous solution, but it would be a non-real solution. So if I plug this in, no, we can do that. We have square root of 1 minus 4 times negative 3/4 equals 2. And this is just a test to see what we get. We would see what we get here, treat this like a grouping symbol. So 3/4 and 4 multiplied together, the denominators would cancel. You'd get 1 minus a negative 3 equals 2. 1 minus negative 3 is really plus a positive. So square root of 4 equals 2. Certainly that's correct. So nothing broke down. We didn't have any problems. Everything's okay. If, when we got to here, we had a negative underneath here, that's an imaginary number, and we have a non-real answer. It's just one thing to be careful about. In the second example, the first step actually does come into play. Remember, first step up here was isolate the radical. The radical's on the right side. It has a +3 that's outside that radical. So the radical itself, this piece, is not alone. Get it alone. So we'll get rid of that 3 by subtracting. You have x minus 3 on the left, square root x minus 3. Now that the radical is isolated, we could get rid of it by raising it to the second power. But we have to do that to the other side too. It'll cancel on the right. You just end up with x minus 3 over there. But on the left, you have x minus 3 squared. That is not x squared minus 9. This exponent is saying we have x minus 3 times x minus 3. And that's something we have to actually distribute. you'd end up with, I'll go through it right now, but I don't want to, in the future, since this is not what this lesson is about, I don't want to waste time with this part. But if you recall, this is how some people multiplied those. We did the box method. You had fill in the box with multiplications. And 9. We have a negative 6x in the middle. So this is x squared minus 6x plus 9. That's our new equation now. And we would solve this as normal as we can, but it's a quadratic. So quadratics are solved most aptly by getting everything to one side and setting it equal to 0, essentially. So we will move this x, subtract an x, and we'll get rid of the negative 3 by adding a 3. So x squared minus 7x, and then this is a plus 12 equals 0. And we need to determine, hopefully this is factorable, otherwise we'd have to use quadratic formula. We have negative 4, negative 3. Negative 4 times negative 3 is positive 12. Negative 4 plus a negative 3 is negative 7. So that works out. And we'd split this up, solve them separately. This is all review right here. This is just a basic solving quadratic by factoring. You'd get x equals 4 and x equals 3. Two legit answers. We should, just very briefly, you don't have to even write this down necessarily, but you would just want to check. Maybe one of these answers is going to make a non-real solution, or make an imaginary number in the square root bar. If that's the case, it's a non-real root, or it's a non-real solution. It's an extraneous solution, meaning it can't really be a solution, but we did it right. So we could plug these in real briefly. X equals 4. So 4 is in here. We get 4 minus 3, which is 1, square root of 1. Yeah, that's fine. There's no problem with that. 3. Plugged in 3 here, you get 3 minus 3 is 0, square root of 0. Yep, that's fine. So if you plugged in either of these, they would both work. No extraneous solutions. Everything's good. Ew. A couple more examples here. Whoa. 3 more examples here. Okay. This is a cube root. You can tell by the index right here. It says it's a third root. First step. They are not. The radical is not by itself. Subtract a 3 rather. This is a 4 equals negative. Don't forget that negative. It's a negative root x plus 11. And I want to say right now that this radical is still not by itself, because that negative sign out front could be a negative 1 times that. And that's the way I want to view it. So I divide by a negative 1, and really all it's going to do is make the 4 over here negative and make the radical over here positive. So I'm not going to write it all down. I'm just going to change the signs, because that's what's going to happen anyway. So if you're wondering how this just happened, rewind. Next, we want to get rid of the radical. It's an index of 3, so we'll raise it to the third power. Negative 4 to the third power is a negative 64. Equals, and then x plus 11 is what we get. The radical canceled out, minus 11. So then we are negative 75 equals x. That is, what do we get? We could plug this in and just very briefly, just check out the radical here. It's we have a 3 minus a cube root of negative 75 plus 11. Now we might be thinking like, uh-oh, this is going to be a negative. And it is, underneath the radical. But it's a cube root. You can have negatives underneath an odd indexed radical. Just not even. So this would be 3 minus cube root. Negative 75 plus 11 is a negative 64. And you could keep going here. This is cube root of negative 64 is a negative 4. 3 minus negative 4. Certainly you get 7 to each side. So this is just checking your answer. And really, I didn't need to check the whole answer. I'm confident I did it right. I just wanted to make sure this wasn't an extraneous solution. Okay, a couple more. Radicals by itself. Booyah. Raise the second power. It's gone. Gotta do it to that side. This is not x squared plus 16. It is a perfect square trinomial when you factor it, and I'm not going to do box method to show you, but you will get, you could pause it and try it, but you'd get x squared plus 8x plus 16. Over here, 4x plus 13. It's a quadratic. Get everything to one side. I would subtract a 4x. And subtracted 13. You get x squared plus 4x plus 3 equals 0. That's factorable. So x plus 3x plus 1. And then your last step, you'll see when you split this up, you're going to get x equals negative 3, x equals negative 1. And I'm going to test this out very quickly just to plug it in just to the radical and see if I get a negative. I don't in either case. Plugged in a negative 3 times 4 is a negative 12 plus 13 is a 1. That's fine. Plug in a negative 1, it's a negative 4 plus 13. Still a positive number. We're fine. Both solutions are okay. All right, the last one. It's a fourth root. Interesting. Not really. Need to get it by itself, so subtract 3. And then we'd have a fourth root of 4x minus 5 equals a negative 2. Nothing tricky here. We got the radical by itself. Then get rid of it. There's the fourth power. That's going to be positive 16. 4x minus 5. We can keep going. Plus 5. Plus 5. 4x equals 21. And divide by 4. X is 5.25 or 21 fourths is fine too. I'd say 20 fourths is probably a little bit better. One thing about this, that we want to say is, let's say I plug this in, and I don't want to waste a ton of time on this. Video is kind of long, but if we had this, I'll use 21 fourths. 4 times 21 fourths minus 5 equals 1. Right here, the 4s would cancel. You get 21 minus 5 is 16. So 4 root, and we get 16, 3 equals 1. 4th root of 16 is 2. So 3 plus 2 equals 1. Yikes. That's certainly not true. However, when you have an even root, your answer in this could technically be a positive or a negative number. So, just like over here, we had a negative 2 to the 4th power and we got 16. If we took the 4th root of 16, how are we to know necessarily if, what number times itself 4 times is 16? How do we know if it was a 2 or a negative 2? We don't. So you could call this, you could look at it and see this and we have no solution, but we do have the case where the 4th root of 16 is a negative 2. And then it does work out. So we're okay. All right, hopefully that was not overly confusing. But really just follow the process. It's the same thing every time. Isolate the radical, raise both sides to that power that you need to get rid of the radical, and then solve. All right, good luck.